Hi, thank you for your time. And my name is Sid Dhuri, and I have the enviable position of standing between you and your lunch. So I hope I can make this time worth your while. And I'm going to talk about feedback loops and how we were able to do that at an insurance company and how we were able to implement feedback loops between claims and underwriting. Now, insurance. How do I go to the next slide? Okay, yeah. So the insurance industry in its current shape started taking shape in the 17th century. And one of the biggest marketplaces for insurance, Lloyd's of London, actually started out as a coffee shop. So in 1687, Edward Lloyd started a coffee house on Tower Street. And the coffee shop became known as a place for gossips on topics including the plague, the Great Fire of London, ships sailing in and out. And then sailors would gather there and gamble and place bets on whether they would arrive safely or not and the cargo that they were carrying. And it became so popular that then Edward Lloyd actually began to assemble a network of reporters and information to help inform the people who were having coffee there, and they were placing bets on the shipping as a value-added service. In fact, he started an intelligence service where he would have runners who would run to the London docks to get some information on the ships which are coming in, what cargo they are carrying in, and then come back and inform the people who are having coffee there. So that was the real-time feedback loop that was there, where runners would go and come back. Now, if I can represent the insurance industry in a very simple form, it's two sides. One is the underwriting side, and the other side is the claims side. So the underwriting side is the one that is going and making promises. If you lose something, I'll fulfill your loss, or if you do something, or if you lost, I'm going. So that they are going to be making promises. Now that side is based on probabilities, gut feeling, and biases and various other things. And then the other side, which is the claim side, so that's the real world. That's where the loss has realized and someone has actually come to you to make that loss. And that's where we are fulfilling those promises. And insurance companies need to maintain a proper balance. It's a balancing act. And what is important, that we are not making too many promises than we can fulfill, and understanding that from the claim side, which is the real world, is very important. So to maintain that balance, what we need is a good flow of information, a feedback from claims to underwriting, and at the same time, from underwriting to claims. And implementing that feedback loop is very critical to maintain that balance. Now, feedback loops exist in many processes and many systems. In fact, there is a feedback loop that governs our natural physiology as well. So right now we're going to go and be having lunch, and once you have food, that food gets broken down into glucose. And when those glucose molecules enter your bloodstream, so they're going to flood your bloodstream, and there's an organ in the pancreas called the islets of Langerhans. So they detect that there is a flux of glucose in your body, and then based on that feedback, they release insulin. And so when insulin gets into your bloodstream, it sort of unlocks the keys into the cells. So then it creates an action for the body cells to absorb the excess glucose into the cells so that they can be converted into glycogen and stored as energy. So, and this is called as a homeostasis, and this is something that keeps your body in balance and keeps you out of trouble. And sometimes the feedback loops can break in organizations in your body. When this feedback loop in your body breaks, it can cause diabetes as we know it. And so taking inspiration from biology and taking inspiration from feedback processes, we try to replicate that. So looking at the feedback loop over here, so the signal is the glucose molecule. So the glucose molecule enters your bloodstream. There is the receptor that is in the pancreas. It's called the islets of Langerhans. That's detecting glucose in their bloodstream. Then there's the control center, the pancreas itself, that controls the release of insulin. So then it releases insulin, which is then the effector, which is the cells, your body cells, who are then take the action to absorb the excess glucose in your bloodstream. So we take this process and we try to adopt it in our case for insurance claims. So over here, the signal becomes, instead of the glucose molecules, becomes an insurance claim. The receptor over here is the claims handler, who's handling the claim, who's adjusting the claims over there. They raise an alert if they see something that is not in order, and then there's a control center, what we call as a coordinator. It could be a business manager, and then they're creating alerts that for an effector, who is the underwriter who's underwriting those policies, to take some action to ensure that we are underwriting the right kind of risks. And so this feedback loop, we try to replicate that as a business process in the organization. So when we started when the business process team created this process, they implemented it using Microsoft Forms and Excel spreadsheets, and the notifications would be sent with Outlook. They tried to do it as effectively as possible, but there's very limitations within Microsoft Forms and Excel. And so some of the challenges with this process were that it was not very effective, and to create an effective feedback, we had to develop application that was easily available. Sometimes the claims adjusters are out and about, or the underwriter is out and about. So if it's easily accessible anywhere, I think that's one of the easiest to capture feedback. Easy to use. With forms, the users had to key in a lot of information. By developing apps, it'll make it easy for them to give feedback. Specific feedback, so when it's difficult for you to give feedback, you just aggregate it for a very long period of time, and after 6 months, you just go and give feedback which might not be very specific, not useful. We wanted the application to be role-based, so the forms it was one form for every user, so you couldn't actually technically see or control what someone sees. So we wanted something that is role-based, based on the effector, the coordinator, and the underwriter. Timely feedback, so introducing SLAs so that it's not just an email that gets sent and then just lies there in your inbox, but can we enforce some sort of a timely SLA? Then tracking actions to ensure that the feedback has been acted upon by, and then taking an overview of the whole process using measurements and monitoring. So we try to see what is the solution that we can bring over here. Now we are data scientists and we do a lot of work either in R and or Python. We wanted to make something, now this was outside of our usual responsibilities, and we wanted to see what is it that we can help them with. So we try to look at what apps so we build Shiny apps that works very easily. It becomes like a website, it's easy to use. But something that is easily available, the claims adjusters, they use iPads or quite often the phone. So we're looking how can we make it a bit more easily accessible. Now a bit of show of hands. Has anyone heard about progressive web apps over here? Oh, that's great. Has anyone actually developed any web apps, or rather, has anyone developed mobile applications over here? Okay, that's great. I developed it once, and I used React, and it was one of very painful experiences. So I'm really happy with Shiny, and so I wanted to develop these mobile applications, and what came across was something called as progressive web apps. Now, what are progressive web apps? So native apps, which is the apps that you install in your phones, the iPhone or Android apps, they have a lot of capabilities, and the web apps, like the websites that you develop with Shiny, so they have a lot of reach. You just need an URL and you can access them. So progressive web apps, just imagine them of like a website that is built using the web technologies, but feels and acts like a mobile application. They are very fast because they use less data, they don't take a lot of space on your mobile device, and you can have push notifications. With a website or a web app, you cannot have push notifications, but with a progressive web app, you can use web notifications. As they're lightweight, they can be accessed on demand, they can be installed without any friction, and can be updated regularly. And they have been around for quite some time. So Twitter uses a progressive web app. It's called Twitter Lite. With that, they saw 65% increase in the pages per session, 75% increase in tweets, and a 20% decrease in bounce rate. Similarly, even the Tinder app has cut the load time because it's a lightweight app. They have been able to cut their load time to 4.9 seconds, thus increasing the number of people who are using Tinder. I hope that's good news. And then, but as I said, we are data scientists and we program mostly in Shiny and sometimes in Python. We are not mobile app developers. Now there is a framework that exists for mobile app development called Framework 7, which has all the components that you can use in developing apps. But we have a Shiny ecosystem, and the beauty of Shiny ecosystem is that a lot of these packages become available. So in Shiny, David Rajon has developed a package called Shiny Mobile that has been quite useful to adopt the Framework 7 in developing a progressive web app, and then combining with all the other apps that packages that we can use in the Shiny ecosystem, we were able to offer a progressive web app in a short amount of time. Now, so the process that you saw before, we were able to replicate or bring everything inside that one app rather than using forms and Excel and other things. We were able to offer one unified app called Loop app, and that was able to do that. So this is the actual process. The three actors, like the receptor, the effector, and the coordinator. And so the actual process is you get a claim as a signal. The claims underwriter or the claims handler actually creates an alert in the system. We also send email notifications because people are still used to email, although you also get a push notification on your app. But then the coordinator then assigns this alert to an underwriter. The underwriter then reviews the alert and then sends an action to the action completed notification to the coordinator and underwriter. And then overall, the business heads or the business head who are managing the process, they can take a look at how many alerts are being raised to having that view of measurement and monitoring of all the alerts. So this is the actual app. As you can see, if you develop the app compared to a Shiny website, so it's, the orientation is different. You can see that the controls, the tab controls are at the bottom, so can be accessed with thumbs. And then there's various controls. So there's the accordion control that looks really interesting on a mobile phone application. And you can add all the good things that you know in Shiny can be easily adopted into a Shiny mobile application. And that's been our experience thus far. Now I'd like to give a short demo of the application. So first of all, the authentication, we use Shiny Manager. So where, first of all, you're logging in as the claims handler. So the claims handler, all he or she has to know is the claim reference number. The app will go and fetch all the data and then populates the information. The claims handler now is selecting what sort of issue or alert that he or she wants to raise. Then they just add some information over there, so making it very easy to give feedback. Once the alert is submitted, they get a notification that we've created this alert, submit it, it will be, and someone will act upon it or someone will coordinate it. Now, as I mentioned, that role-based access, so as this is the claims handler, he can look at the alerts that need to be assigned, and so you can see that accordion control and you can see that there is a SLA, so this one is overdue, the other one is just created just now. So now we log into the application as the coordinator, where I will see a different sort of, for the same page, I'll see a different UI. So once the coordinator logs in, he looks at the alerts that need to be assigned, and we are able to manage a role-based UI for, so now instead of just the alert, he's able to see the action that he can do, and so he is able to now assign the specific alert to an underwriter. Now I'll log in as the actual actor, which is the claims underwriter. When the claims underwriter logs in, they can look at the alerts that they have to act upon. So once again, based on the role that you are doing, we are able to offer a different user experience based on your login credentials, and then they create an action that is completed, and then they can complete the action, or if they wanted to forward it to a different underwriter, they can do the same thing. And once we start capturing all the alerts, then we are able to also measure and monitor. So as we are recording alerts, we are able to see what sort of alerts are being raised, what are the issues that we are seeing in the real world with all the claims that we are dealing with, and which business area is we creating a lot of alerts, and what can we do better to ensure these. We can also export the data. So an auditable trace is maintained. With most financially regulated industries, it's very important to maintain an audit process. So this way, creating an effective feedback process was achieved using R and Shiny. Now this was a very different case than what we are usually using R for, mostly for data analysis or machine learning. But we tried to use it for creating an effective process. And it was developed in a very short span of time. And not a complicated project, as you can see, but we were able to deliver a quick win, a useful benefit in a very short span of time. Now I'll leave that with you a single quote, which is that the single biggest problem in communication is the illusion that it has taken place, by Bernard Shaw. So there's a lot of feedback loops or communication mechanisms, processes that exist in organizations, but putting systemic controls in a way that they become effective is very important. So this was an example where we did that. Okay.